Okay, so we're going to go through the Unit 4 final exam review. And we start by looking at the unit circle, our old friend. Now, this circle has a radius of 1. So if we start looking at the points where this circle hits this x and y axis, this point right here is going to be 1, 0. This is 0, 1. This is negative 1, 0. Down here, we're going to have 0, negative 1, again, because this is the origin at 0, 0. Now, this first angle is going to be 0 degrees, and then we look at 30 degrees, 45, and 60. Now, these are the important ones that we will be looking at. And so if we think about what we're going to have in terms of these angles, of course, and 90 degrees. More importantly, we want the radians. And so 30 degrees is going to be the same as pi over 6. And the easy way to see that is that 180, which is over here, divided by 30 is going to be 6. Over here, this is going to be pi over 4. And why don't I just use this as my fraction bar? So pi over 6, this is pi over 4, and finally pi over 3. Let me clean up that 4. Of course, this right here is going to be pi over 2. Now, 180 degrees is pi. And of course, 360 degrees, or 0 degrees, is 0, or 2 pi. Down here, this is going to be 3 pi over 2. And we can see that that is going to be 270 degrees. So if we think that this is an interval of 45 degrees, so 0, 45 degrees, then, well, let's go through with radians. So we got pi over 6, pi over 4, pi over 3. The pi over 4s are going to be here. And then 2 pi over 4s, of course, pi over 2. Then we have over here, this is 3 pi over 4. This pen is acting up. 3 pi over 4. 4 pi over 4 is just, again, 1 pi. Then we have 5 pi over 4. Then 6 pi over 4, which can be reduced to 3 pi over 2. 7 pi over 4 is down here. And finally 8 pi over 2, which is just 2 pi. And actually, I can see that there are 2 spots down here. So this is 0, 0, and also 360 degrees, which is 2 pi. Now, the pi over 4s count by intervals of 45. So 45 degrees, 90 degrees. 90 plus 45 is 135. 135 plus 180 is 45. 135 plus 45 is 180. 180 plus 45 is 225. 225 plus 225 plus 45 is 270. And 270 plus 45 is going to be 315, which if I add another 45, I'm going to get 360. These intervals of pi over 6 and pi over 3 are very much related. If I have pi over 6, I can count the entire way by pi over 6. So pi over 6, that's 1 pi over 6. 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 can be reduced to 2 pi over 3. Then we get 5 pi over 6, which can't be reduced. 6 pi over 6, which is just pi. 7 pi over 6, which would be right there. 8 pi over 6, which can be reduced to 4 pi over 3. 9 pi over 6, which can be reduced to 3 pi over 2. 10 pi over 6, which can be reduced to 5 pi over 3. And then finally 11 pi over 6, before ending at 12 pi over 6, which is 2 pi. in terms of the degrees, for us, the degrees aren't going to be very important. But again, we're counting by intervals of 30. So we get 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. So if we want to think about what these coordinates are going to be, there's actually a very nice pattern here. And so the cosine of pi over 6, if we can just remember that much, then we'll be able to figure the rest out. So the cosine of pi over 6, which is the x-coordinate, is root 3 over 2. Then looking at my cosines, I'm going to go root 3 over 2, root 2 over 2, and then finally root 1 over 2, which is just 1/2. And this is actually going to continue all the way around. My y values are going to start at 1/2. Actually, my y values are going to start at 1/2, and they're going to go from 1/2 to root 2 over 2 to root 3 over 2. So while my cosines are counting down, my sines, my y values, are counting up. And this will continue all the way around the circle. So for my cosines, my x values, I'm going to have root 3 over 2, root 2 over 2, 1, 0. Then over here, I'm going to have negative values. So this is going to be negative 1, negative root 2 over 2, and negative root 3 over 2. So root 3, root 2, 1, 0. 1, 2, 3, 1. And then again at pi over 6, now here my x value is again still negative. So I'm going to have still negative root 3 over 2, negative root 2 over 2, and negative 1/2. Over here, my x values are positive again, so I get 1/2 root 2 over 2 and root 3 over 2. So it's a nice cycle. For my y values, I go 1, 2, 3, 3, 2, 1. And over here, my y values are positive, so they stay positive. But down here in quadrant 3, my y values are negative, so I'm going to have negative 1/2, negative root 2 over 2, and negative root 3 over 2. Over here, my y values are still negative, so I'm going to have, again, negative root 3 over 2, negative root 2 over 2, and negative 1/2. So this is a unit circle, so make sure you, again, at least know the radian values and the points that they intersect the circle. Right, so when we have to evaluate these functions, we have to evaluate the 6 trigonometric functions. So I'm going to do sine of pi over 3, cosine of pi over 3, tangent of pi over 3, and of course cosecant of pi over 3, secant of pi over 3, and cotangent of pi over 3. So the sine, that is again the y value. So if I use this as a reference, the y value is root 3 over 2. So the sine is just root 3 over 2. And the cosine would be 1/2. The tangent would be y divided by x. So root 3 over 2 divided by 1/2. That's the same thing as root 3 over 2 times 2, which is just root 3. Over here, I'm going to have all of the reciprocals. So this will be 2 over root 3, but I can't have that irrational in the denominator. So once I rationalize it, I get 2 root 3 over 3. Over here, I get 2. And over here, I get, instead of 1 over root 3, square root of 3 over 3. And so that gives me my values for pi over 3. 3 pi over 4 is a little bit nicer, so I have sine of 3 pi over 4, cosine of 3 pi over 4, tangent of 3 pi over 4, cosecant 3 pi over 4, secant 3 pi over 4, cotangent of 3 pi over 4. Right, so sine. This is 3 pi over 4, which means it's going to be in quadrant 2. So the sine is going to be positive. So that's going to be root 2 over 2. The cosine, that's going to be negative, so negative root 2 over 2. And when I divide these, I get negative 1. If the tangent is negative 1, the reciprocal cotangent is also going to be negative 1. Cosecant, that's going to be the reciprocal. So if I put 2 over root 2, I'm going to get 2 root 2 over 2, which is just the square root of 2. And so that means that the secant would be negative square root of 2. Running out of room here, I'm going to have to go just down the list for 7 pi over 6. So sine of 7 pi over 6, cosine of 7 pi over 6, tangent of 7 pi over 6, cosecant of 7 pi over 6, secant of 7 pi over 6, and finally cotangent of 7 pi over 6. Right, so again, 7 pi over 6, that's actually going to be in quadrant 3. And so in quadrant 3, the sign is again negative. Now whenever I have a pi over 6, my sine value is going to be 1/2. And so again, we can use this unit circle to show that the sine value is negative 1/2. So that means that the cosine value is going to be negative root 3 over 2. The tangent is y divided by x. So it's 1/2 divided by negative root 3 over 2. So that would actually look like this. And then so when I rationalize that, because if I'm dividing, I'm multiplying by the reciprocal. When I rationalize that, I'm going to get positive root 3 over 3. So if that's going to be the tangent, then the cotangent would be a positive square root of 3. Sine, sorry, if the sine is negative 1/2, then the cosecant is negative 2. And if the cosine is negative root 3 over 2, then the secant is going to be the reciprocal, so negative 2 over root 3, or negative 2 root 3 over 3. So there are some similarities here with these other values. Moving on, we get some negative values now. So if I set this up, so the sine of negative pi over 2, cosine of negative pi over 2, tangent of negative pi over 2, cosecant, secant, and finally cotangent. Well, if I have this negative pi over 2, remember a negative value just means that I'm moving in the clockwise fashion. So if I go in the negative direction for pi over 2, I end up at 3 pi over 2. So I'm just looking at the values for 3 pi over 2. So what's the sine? What's the y value for negative pi over 2 or 3 pi over 2? The y value is negative 1. The cosine is 0. Cosecant is going to be reciprocal, so that's going to be a negative 1. And the secant is going to be 1 divided by 0, which is just going to be undefined. Now, the tangent is going to be y divided by x, so negative 1 divided by 0, which is undefined. But the cotangent would be x divided by y, or the cosine divided by the sine, which would be 0 divided by negative 1, which would be 0. So those are my values there. for the negative 4 pi over 3. This is moving again in the clockwise fashion. So if I look, negative 4 pi over 3 is greater than 3 pi over 3. It's more than 180 degrees. So I'm actually going to end up here at 2 pi over 3. So this is going to be a positive 2 pi over 3. I realized I missed a 2 there. So if I set this up, sine of negative 4 pi over 3, cosine, tangent, cosecant, secant, and finally cotangent. The sine is the y value, and again, this negative 4 pi over 3 is really just 2 pi over 3. And so for 2 pi over 3, the sine of 2 pi over 3, as we can see here, is root 3 over 2. So that's square root of 3 over 2. And so the cosine is a negative 1/2. And so when I divide root 3 over 2 times negative 1/2, I get a negative root 3. And so hopefully we can see the pattern here that the cotangent is going to be negative root 3 over 3. The secant is going to be a negative 2. And the cosecant is going to be 2 root 3 over 3. That's just a process of reducing the radical, rationalizing the denominator. All right, and finally we have the 6 trigonometric functions of negative pi over 6. So cosine, tangent, cotangent, not cotangent. It's been a long day, right? So cosecant, secant, and finally cotangent. There it is. So negative pi over 6 means I'm moving in the clockwise direction. So that's going to be 11 pi over 6. So the sine of 11 pi over 6, again, looking and referencing that unit circle, 11 pi over 6, the sine is a negative 1/2. So if the sine is 1/2, then the cosine must be root 3 over 2. Because this is a quadrant 4, the cosine will be positive. The tangent is sine divided by cosine. So that's going to be negative 1 over root 3, which is negative root 3 over 3. So if that's the tangent, the cotangent would be a negative square root of 3. The sine would be a negative 2. And then the secant would be a 2 root 3 over 3. Again, because flipping this would give me that denominator. That's irrational. So these are just basic values. As long as you know the sine and the cosine, and that comes from knowing the unit circle, or at least being able to recognize the pattern in the unit circle, then you can get the other 4 values just by some simple algebra. Now these problems are the simple SOHCAHTOA problems. So I don't know what theta is, but I want to find the 6 trigonometric values. So sine, cosine, tangent, cosecant, secant, and cotangent. So the sine is, this is actually y divided by r, cosine is x divided by r, and tangent is y divided by x. So cosecant is r divided by y, secant is, secant is r divided by x, and cotangent is x divided by y. And we know from the unit circle that the sine is the y value, but technically it is y divided by r, it's just that the radius is 1. Here, this radius is not 1. for these right triangles, the radius will always be the hypotenuse. So if we want to find the value of the hypotenuse, I have to do a squared plus b squared is equal to c squared. So I get 20 squared plus 15 squared is equal to c squared, which we can say is the radius squared. So this is going to be 400 plus 15 squared. Whoops. Not 15 to the fifth. 15 squared is 225. And so if we add that to 400, we're going to get 625. And I can say that that's equal to r squared. So that means that r is going to be 25. And so the sine is, if you remember SOHCAHTOA, sine is the opposite, which is 15 over the hypotenuse. Since they both have a common factor of 5, 15 over 25 reduces to 3 over 5. The cosine is the adjacent over the hypotenuse, or x over r, and that's going to be 20 over 25, which can reduce to 4 over 5. And the tangent of theta, which is the opposite side over the adjacent side, is 15 over 20, which is, again, because they have a common factor of 5, reduces to 3 over 4. And so my cotangent is going to be the reciprocal, my secant is going to be the reciprocal, and cosecant as well. So that worked out rather nicely for that one. Nice integer values reducing to rational fractions. But that's not always the case. So here I have sine, cosine, tangent, cosecant, secant, and cotangent. So here, again, I need to find this value here, which I guess we can call b or a or whatever. So b, so I get 8 squared plus b squared is equal to 4 root 13 squared. Now 8 squared is 64, and that's great. But this 4 root 13, remember, you are squaring the 4 and the square root of 13. So the square root of 13 squared is 13, but 4 squared is 16. So if I multiply 16 times 13, I get 208, leaving with b squared to be 144, or b to be equal to 12. So now if I say the sine is going to be equal to this is my reference angle. The sine is the opposite side, which is 12, over the hypotenuse, which is 4 root 13. So that's 3 over root 13, but I need to rationalize my denominator. So I get 3 root 13 over 13. Now if this is if this is 3 over root 13, then the reciprocal would be root 13 over 3. There's no need to rationalize both parts. The cosine is going to be the adjacent side, which is 8, over the hypotenuse, which is 4 square root of 13, which will be 2 over root 13, or so 2 over root 13, which would be 2 root 13 over 13. 2 over root 13. I would flip this to be root 13. Right. So again, 2 over root 13. This reciprocal for the secant would be root 13 over 2. And the tangent would be the opposite over the adjacent. So that's 12 over 8, which we can reduce to 3 over 2. So the cotangent must be 2 over 3. Nice little SOHCAHTOA problems. Continuing on here. This is a nice right triangle. So actually what I'm going to do to save me some time, write sine, cosine, tangent, cosecant, secant, cotangent. And so actually, if I can copy these without rotating them, that'd be great. Copy and paste. Now I'm all set. Okay, so here we again need to find this opposite side. So we have the hypotenuse, but we need to find the opposite side. So a squared plus 12 squared is equal to 13 squared. So that's a squared plus 144 is equal to 169. So a squared is equal to 25. So a is equal to 5. Beautiful. So the sine is the opposite, which is going to be 5 over the hypotenuse, which is 13. Cosine is the adjacent side, which is 12 over 13. Tangent is going to be opposite of 5 over the adjacent of 13. And then so I can just find the reciprocals. Again, no irrational values there. Here, this is actually 15, and that's 15 root 2. So this side is 15. This is a 45, 45, 90 right triangle. And again, if you don't realize that, you can still use Pythagorean theorem to find that this is 15. But the SOHCAHTOA rules, opposite side, if this is here, I'm going to have the opposite, which is 15, over 15 root 2 reduces to root 2. So that's going to be square root of 2 over 2. And then so this cosecant would just be the square root of 2. Cosine would be the adjacent side, 15, over the hypotenuse. So again, root 2 over 2, with the secant again being square root of 2. And the tangent would just be the opposite over the adjacent, which would be 1 and 1. Look familiar? Now with these problems, we again need to use this value here, or these trig functions, but again we need to find out what r is. And so, without spinning anything there, if I copy my trig values for each of these, and draw a nice little line to separate these problems, clean this up a bit. Right, so we want to find this. So x squared plus y squared is going to give me r squared. So that means that 16 plus 9 is 25. Oops, I ruined the surprise. R squared. So 25 is equal to r squared, so r is equal to 5. So again, sine is y over r, cosine is x over r, and tangent is y over x. All of these reciprocals are going to be the cosecant, secant, and cotangent. Over here, I get x squared plus y squared, which is going to be r squared. The radius is always going to be a positive value because it's a distance. So if I have negative 8 squared, that's 64. And 15 squared is going to be 225. So if I add those two together, I get 289, which is r squared. So actually r is going to be equal to 17. So sine is negative 15 over 17. Cosine is going to be negative 8 over 17. And the tangent would be negative 15 over 8, which would be a positive. And so again, if I fill in my reciprocals here, I get my other values. I don't like how that negative sign looks. Let me fix that. So now I ruined this. Okay. Over here, x squared plus y squared equals r squared. So I get 1 plus 1 equals r squared. So I get that r is actually here going to be the square root of 1 plus 1, which is 2. So the sine is y over r, so 1 over root 2, which is going to be the square root of 2 over 2. Cosine, which would be the same value except just negative. And so that means that this will be root 2, this will be negative root 2, because when I have the reciprocal, I have to rationalize the denominator. And when I divide sine by cosine, I get a negative 1. Cosecant by secant, again, a negative 1. For these problems, I want to continue doing the same thing. So for all of these, I, again, will need to find my radius. So let's build some fences here. Right, so x squared plus y squared is equal to r squared. So it gives me 144 plus 25 is equal to r squared. So this is 169 is equal to r squared. So r equals 13. So this is negative 5 over 13. Cosine is 12 over 13. And the tangent would be negative 5 over 12. So if I again find all of these reciprocals, then I get these nice values. It's quick and easy when there aren't any rational values. Here, unfortunately, I'm going to have an irrational value because I'm going to have x squared plus y squared to give me r squared. So that's going to give me 9 plus 1 is r squared. So 10 is equal to r squared. So r is equal to the square root of 10, which cannot be reduced. And so this is going to be 1 over the square root of 10, which is root 10 over 10. So that means that the cosecant is going to be the square root of 10. This will be 3 over the square root of 10, which would be 3 root 10 over 10. So if the cosine is 3 over the square root of 10, this will be the square root of 10 over 3. And then the tangent is, of course, y divided by x, which is 1/3. And the cotangent would be 3. Over here, x squared plus y squared is equal to r squared. So x squared would be 1. Negative root 3 squared would be 3. And that's going to be equal to r squared. So 4 is equal to r squared. So what do you know? That r is equal to 2. So the sine would be negative root 3 over 2. The cosine would be negative 1/2. Ooh, look familiar. And the tangent would be negative square root of 3. So again, actually, if I can give myself some more space there. Which I don't think I will be. Okay, not a big deal. I'll try and squeeze it in here. Actually, I could slide this part over. Because the tangent, if I take the reciprocal there, that will be negative square root of 3 over 3. Secant would be negative 2. And cosecant would be negative 2 root 3 over 3. Some nice values there. All right, off to reference angles. So for the following angles, we want to find the reference angle. Now, the reference angle is just getting back to the x-axis. So actually, if I try looking at these ones first, where I actually have a picture, I want to get back to the x-axis. So this x-axis, this is pi, which is 9 pi over 9. So if I've gone 13 pi over 9, and I want to get back to 9 pi over 9, I subtract them, and I get 4 pi over 9, which is my value. Over here, the closest value for the x-axis is 2 pi, which is the same as 8 pi over 4. So here, I've gone 9 pi over 4, and so if I have 9 pi over 4, and I subtract this 8 pi over 4, I get pi over 4. Now don't worry that this is a negative 9 pi over 4, because really what we're doing here is we're looking for a reference angle to be in the first quadrant. So this allows us to take a distance, or distance, which will be the absolute value. So as long as this is positive, when we can see that this is a positive distance, we're good. So for these, when we don't have a picture, it's a little bit more difficult, but not horrible. If you think about it, we're looking for values, multiples of pi or 2 pi. So that would be 4 pi over 4, 8 pi over 4, and 12 pi over 4. Well, we can see 12 pi over 4, we can see is closest to 11 pi over 4. And so this 12 pi over 4 minus this 11 pi over 4 is going to be equal to pi over 4. And so that is my reference angle. For here, I'm going to have a negative 7 pi over 3. So what would actually help us out here is if we find a positive coterminal angle. So if I add 2 pi, I get negative pi over 3 still. So if I add another 2 pi, I get 5 pi over 3. And so the x-axis is closest to 2 pi, which is 6 pi over 3. If I subtract that 5 pi over 3, I get a reference angle for pi over 3. Over here, 23 pi over 9. Again, if I look at values of, or multiples of pi, that would be 1 pi, and 18 pi over 9 would be 2 pi. So if I've gone 23 pi over 9, and I subtract 2 pi, which is, I don't know what I was trying to do there, 18 pi over 9, then this gives me 5 pi over 9. Finally, 4 pi over 3. The closest value is pi, which is 3 pi over 3. So if I have 4 pi over 3, I've gone that, and I've gone too far. I need to turn back to 3 pi over 3. I get a reference angle of pi over 3. Nice, quick, and easy. So sometimes if you draw a picture, that might help. But otherwise, again, you're just looking for the shortest distance to get back to the x-axis, which is going to be some radian value between 0 and 2 pi, which is 0 and 90 degrees. So when we're looking for positive and negative coterminal angles, we want to add and subtract 2 pi. So 2 pi here is going to be 8 pi over 4, which we need because we have to have a common denominator. So that gives me a 9 pi over 4. And if I subtract 8 pi over 4, I get a negative 7 pi over 4. So that's my answer there, and that's it. For negative 17 pi over 12, again, I'm going to add and subtract 24 pi over 12. That's 2 pi with a common denominator. If I add 24 pi over 12, I get 7 pi over 12. And if I subtract, I'm going to get negative 41 pi over 12. Took up too much room there. Negative 3 pi over 4, I'm going to add and subtract again 8 pi over 4. This will give me a positive 5 pi over 4 and a negative 11 pi over 4. Adding and subtracting a positive, actually this is a good one, because if I look here, if I subtract 2 pi, or 12 pi over 6, I get pi over 6. So that's actually not giving me a negative value. So I need to subtract another 12 pi over 6, which is going to be negative 11 pi over 6. Here, if I add 6 pi over 3, I'm in positive territory. I get pi over 3. And if I subtract 6 pi over 3, I get negative 11 pi over 3. Same thing with number 4 for number 6. If I subtract 18 pi over 9, which again is 2 pi, I have a positive value of 2 pi over 9. So I need to subtract another 18 pi over 9 to get a negative value. And that's going to give me a negative 16 pi over 9. So that's coterminal angles. I know that when we did this before, a lot of people convert it to degrees, but that's really not necessary as long as we add and subtract 2 pi. Here we want to convert these to radians. So in order to convert these to radians, which got these a little bit out of order, but that's fine. I'm going to convert these to radians. And so when we convert that to radians, we're going to multiply these by pi over 180 degrees. And then it's just a matter of reducing the fraction. So if I have 520 over 180, that's negative 26 pi over 9. 315, if I multiply that by pi over 180 degrees, actually, if you remember, that's one of our values on the unit circle, and that's going to be 7 pi over 4. Negative 650 degrees, again, I multiply by pi over 180 degrees, and so I get 650 pi over 180, which with a negative in front is negative 65 pi over 18. And finally, for 840 degrees, we have 840 pi divided by 180, which we can reduce to be 14 pi over 3 radians. Now, when I'm converting to degrees, I switch it. I multiply by 180 degrees over pi. And so here I have 23 times 180, and I divide that by 18, and this gives me 230 degrees. With the negatives, it's still the same thing. I want to multiply by 180 degrees over pi, and we can see that the pi's cancel out. So this is going to give me a negative 120 degrees, because 2 times 180 is negative 360, divided by 3 is negative 120. Again, we multiply by 180 degrees over pi, and we get 11 times 180, and then we divide that by 12 to get 165 degrees. And the last one here, 180 divided by pi. If I do 14 times 180 and divide that by 3, I get a rather large angle at 840 degrees. Of course, with a negative outside, it's negative 840. So that's pretty straightforward and pretty good. However, where we really use this is with using and finding arc length. So the formula for arc length is S equals R times theta. And so the radius is given, but the central angle must be in radians. So if it's not, we need to convert. Here it is. So it's just 5 pi over 4 times 13. And so 5 times 13 will give me 65 pi over 4. And so I can actually leave my answer like that. 65 pi over 4. That looks horrible. Let's write that a little bit better. 65 pi over 4. And since we're talking about a length, it's going to be kilometers. Now here we need to convert this, but 90 degrees, hopefully we realize that's pi over 2 radians. And so S equals R times theta. So we're going to have S is equal to the radius, which is 13, times the theta, which is pi over 2. So we can multiply this and see that this is just going to leave us with 13 pi over 2. And again, our length is going to be centimeters. That's really straightforward and nice. But now what if we don't have the radius? Well, again, we can use S is equal to R times theta. And here we have that the arc length is equal to 10 pi. We don't know the radius. However, we have that the central angle is 5 pi over 6. So if I think about some algebra, if I multiply both sides by 6 over 5 pi, they cancel out. The pi's cancel out. And so here, 10 pi divided by 5 pi is 2. So I get 6 times 2, which is 12. So the radius is 12. Now if the arc length is in feet, so is the radius. Here the central angle is given in degrees. So again, I need to convert this. So I multiply this by pi over 180 degrees. And so that ends up giving me 3 pi over 4. So that's the measure of the central angle. But again, I need to set up my equation, s equals r times theta. If s is equal to 51 pi over 4, and theta is equal to 3 pi over 4, I can multiply both sides here by 4 over 3 pi. And 51 divided by 3 is going to give me 17. The 4's cancel out, the pi's cancel out. So I get that the radius is just 17. And again, it's going to have the same unit as the arc length, which is inches. For these two problems, I don't have the central angle, but I have the arc length and the radius. So again, s is equal to r times theta. So if the arc length is 39 pi over 2, and I have that the radius is 13, and I'm looking for theta, I can divide both sides by 13, or multiply by 1 over 13. 39 divided by 13 can be reduced to 3 over 1. So I end up getting 3 pi over 2 for my central angle. This is automatically in radians because the arc length is calculated by using radians. Over here, s equals r times theta. Again, the arc length is going to be 33 pi over 4. The radius is 11, and we're solving for theta. So if I multiply by 1 over 11 on both sides, 33 and 11 reduce to 3 over 1. So I get 3 pi over 4 for theta, again, being in radians. Now for sector area, the formula here is going to be theta divided by 2 times r squared. So I have that my central angle is 11 pi over 12. If I divide that by 2, that's the same as multiplying by 1/2. So this is going to give me 11 pi over 24 times 8 squared, which is 64. And so if I do 11 times 64, that's going to be 704. 704, actually better yet, 64 and 24 both have a common factor of 8. So I can reduce that to 3 and this to 8. So I get 88 pi over 3. Now, if the radius is centimeters, the sector area, because its area is going to be centimeters squared. Again, here we have 45 degrees. We need to convert this, but hopefully we realize this is pi over 4 radians. And so if we have theta over 2 times r squared, again, theta over 2 is just this angle multiplied by 1/2. So we get pi over 8 times 11 squared, which is 121. There's nothing to reduce there, so we get 121 pi over 8. So this is 121 pi over 8 centimeters squared. All right, here we need to find the radius. So the sector area is 75 pi, and that's equal to theta divided by 2, which is 3 pi over 4 times r squared. So I'm going to multiply both sides here by 4 over 3 pi. And notice that 75 pi and 3 pi reduce to just 25. So 4 times 25 is 100. And I get 100 is equal to r squared. So r is equal to 10. Well, if the area is feet squared, the radius is just in feet. Sector area here is 63 pi over 2, and that's going to be equal to theta divided by 2. Whoops, but we need to convert this theta first. And so we're going to multiply this by pi over 180 degrees. And so we have 315 divided by that 180 will reduce to 7 pi over 4. Now if I take 7 pi over 4 and multiply it by 1/2, I get 7 pi over 8. And this is r squared. So again, if I multiply both sides by the reciprocal, 8 over 7 pi, the 7 pi and the 63 reduce to, actually I can change this colors, right? This reduces to 1 and 9, and then the 2 and the 8 reduce to 1 and 4. So I end up with 36 is equal to r squared, so r is equal to 6. The radius is equal to 6 miles, since the sector area is miles squared. And finally, we have this where we have to find the central angle if we are given the radius and the sector area. So again, this sector area, 490 pi divided by 3, is equal to theta divided by 2 times r squared. Well, 14 squared is going to be 196. And so 196 divided by 2 is 98. So I get 490 pi divided by 3 is equal to 98 times theta. So if I want to find theta, I have to divide both sides by 1 over 98. So I have to do 490 divided by whatever 98 times 3 is. And if I work that out as a fraction, I end up getting 5 pi over 3, just with some nice reducing of fractions. And finally here, we have the sector area is 245 pi over 6. And again, this equals theta divided by 2 times r squared. But again, r is equal to 14 squared. From the previous problem, we know that 14 squared is 196. And so 196 divided by 2 is again going to give me 98. So I get 98 times theta is going to be equal to 245 pi divided by 6. So if I multiply both sides again by 1 over 98, I can take 245 and divide that by 98 times 6. And if I reduce that as a fraction, that's going to be 5 pi over 12, which is my central angle in radians. And I believe that's it. So we went through a lot of this fairly quickly. A lot of algebra, a lot of manipulations going on in there. But as long as you know the formulas, as long as you know the relationships, and especially that unit circle all the way back in the beginning, then you really are set. You really are set for Unit 4 for the final exam.